present you how to calculate pressure losses in a ventilation duct. So the first thing to do when you open the file is to determine the characteristic of your air. First thing is to put the good temperature. In this case, we're going to choose 60 Fahrenheit degrees and an altitude of, for example, 200. And we have to choose also the increase in pressure losses for increase the different total that you have here. I'm going to put 10, for example. It's just an example. There you can mark a title of calculation. I'm going to mark title, no, not title, but calculation test. Okay, so this you have to know that these two parameters make change these two thermodynamic value, the density and the air kinematic viscosity, which is used to calculate all your pressure losses. That's why it's very important to put the good temperature and the good altitude of your installation. So now we are going to calculate the pressure losses of this installation. So the first thing to do is to find the worst way for the air. In this case, it's this way because it's the far way. Oh. And on this part, we have three different flows, this one, and this one. We're going to say that this part is rectangular, this one is circular, and we can start. So so the first part is this one with the flow of 12 and 16 600 meters per hour, and I've got 14 and 12 meter. So I'm going to add these two length. So it's 26. The airflow is 12,600. The material is the galvanized tile, but I can also choose another material. If I choose, for example, PVC, the rigidity is going to be this one, but if I choose galvanized tile steel, it's 0.15. The form is rectangular. The measurement in this case it's 800 and 600, like this. And at this moment the calculator is already able to calculate the linear losses, which is in this case 17. And now we have to find the point losses of this part. So we have one rectangular elbow, another one, and a straight T. So I'm gonna mark the straight T of 90 degrees, so this one. And also we've got three rectangular elbow of 90 degrees. So we can see that it's a zeta of 0.36. And we can directly mark there the addition of these three zeta. So 1.08. And the calculator now can know the point losses. It's 37. So it was the section 1. Now we are going to calculate the section 2. The section 2 is this one. The airflow is 5,400 and the length is 32. And we've got just one elbow and one bifurcation T. So 32 The airflow is this one. It's still galvanized style, but this time is circular, and the diameter is 500. We got, like I said, a circular elbow of 90 degrees and a straight, not a straight, but a T bifurcation, sorry, of 90 degrees. So it's this one. So I can mark directly there. The section 2 is already finished. We can make the section 3. Section 3, it's just one elbow and 18 meters of duct with a flow of 3,600. It's still galvanized steel, circular, the same internal diameter, and just one circular elbow of 90 degrees. At this moment, the calculation of our installation is already finished. We can also mark directly a value of added pressure losses. For example, if we have an equipment, for this case, it could be, I don't know, but maybe a sun trap there. Yes, a sun trap, for example, if we have a sun trap and we know that for a classic sun trap, it's around 16, no, not 16, 60 Pascal. We can put directly there 16 Pascal, and the calculator is going to add this value with the pressure losses calculated by the zeta here. So for the total of this installation, we have a total pressure losses of 255. So the video is finished. If you want to get this calculator, you can send me an email on my address email in the description. And it's possible to get this calculator for $50. Bye bye.